Hello everyone, we will discuss about scenario based methods. In scenario based methods, first we will discuss about overall objectives and philosophy of requirements analysis and few analysis rules of thumb for requirements analysis and domain analysis, after we done the requirements analysis and requirements modeling approaches. Okay, after that we will discuss about scenario based modeling. Scenario based modeling is a part of requirement modeling approaches, one of the requirements modeling approaches. In scenario based modeling, okay, we will discuss about how to create a preliminary use case with the example and what we to do now refining a preliminary use case, what questions we should ask for refining the preliminary use case, and then after that we discuss about writing the formal use case with the example. Then sometimes use case is not sufficient to represent the requirements in user perspective. In such scenario we go for another diagrams that can help the users understand what the requirements would look like in from their perspective with the help of activity diagram and Swimlane diagram. Okay, so let's dive into the topic. So requirements, as I mentioned, requirements analysis is nothing but taking the requirements from the different stakeholders who uses this system. Okay, so after the result of this requirement analysis should be operational characteristics of the software which you are going to build, and it indicates the software interface where where different entities can able to deal with it, and different constraints that software should meet. Okay, so that's the result of this requirements analysis. Okay, so after some requirements analysis, modeling should meet one of the following type of models. Okay, scenario based models. Okay, scenario based models in the sense requirements from the perspective of the user or actor, and data models that can able to understand how information is flowing throughout the system. Okay, information domain of the system. And then we do have class oriented models, that means viewing the system in object oriented perspective. Okay, and what are the classes, attributes and operations and how they collaborate each other and so on. Okay, and then flow oriented models, how data flows, how which function triggers which action. Okay, like that, how data move through the system, right? So that's we'll discuss about the flow oriented models. Then last but not least, behavioral models. Okay, behavioral models help you depict how the software behaves, the consequences of the external events. Okay, so all these things are the resultant of the requirements analysis. All these models are the resultant of requirements analysis. Okay, so yeah, then coming to the overall objectives of the requirements analysis, is the requirements model should achieve the these primary objectives. What are those? First, it can able to describe what customer requires. That's the first objective of requirement analysis. And second one is it can able to establish basis for the creation of software design. Okay, so that is the primary source for to create the software. And the third one is it can able to set a few requirements that can able to validate the software. Okay, so after you develop the software, you could validate the software with the help of these models. Okay, so that is the primary objectives of the requirements analysis, right? So then the philosophy here is, okay, so there would be a analysis model that can able to bridge the gap between system level description and and other system elements. Okay, that is a software design. okay, that can able to describe how software application work in the terms of its architecture and user interface and component level structure. Okay, so in the pictorial representation, that would looks like this. Okay, sorry, in the pictorial representation, that would look like this analysis model that can able to bridge the gap between system description and design model. Okay, so yeah, so with the help of analysis model, we can able to we can't able to differentiate all these two models. Okay, so that can able to see here. Yeah, all the elements of the requirements model will be directly should be directly traceable to the parts of the design model, and we can't able to clearly divide the entities or divide the things between these analysis model and other design model or system description, right? Yeah, some design might be occurs as a part of analysis, but some analysis will be conducted during the design. Okay, so that's the much information about the analysis model. Okay, so then coming to the coming to the few analysis rules of thumb about requirements analysis is as per Arlo and News added. Okay, so they suggested few analysis rules of thumb. Okay, so one of them is the model should focus on requirements that are visible within the problem. Okay, so our business domain, we will discuss about business domain later, but as of now we can now concentrate on the model should able to focus on the requirements which are specific to that system or specific to that problem. Okay, and the level of abstraction should be relatively high. That means the level of abstraction should be relatively high, and each element of the requirement model should add to an overall. Okay, if you are adding an element to the requirement model, that should add to the overall requirements analysis. Okay, so that means understanding the software requirements that can able to provide insight to the information domain. Okay, and the functionality of the system and behavior of the system. Okay, so don't start developing the system until you done with the design. That's the last analysis rule of thumb. Yes, you can't able to you should not start the construction of the system until you finishes the design. Okay, so these are the few rules of thumb, and a few more are okay. So minimizing coupling throughout the system. Coupling in the sense means dependency. Okay, so minimize the coupling. That means what you should you do less coupling as much, less dependent, as much as you can in the design phase only. Okay, so that it would be very helpful in the construction phase, right? So whatever the elements you add to the requirements model, those should provide a value to all the stakeholders. Okay, that is one more analysis rule of thumb. And the last but not least is keep the model simple as simple as possible. Okay, so that's the last analysis rule of thumb for the requirements analysis. Okay, so next is domain analysis. Domain analysis in the sense means whatever the software you develop, okay, that falls into any one of the domain, one or more domain categories. Domain categories in the sense means, for example, take airline systems, banking and retail, okay, life insurances, okay, FMCG. Okay, these are few domains. Okay, so why do we do the domain analysis? According to Firesmith, okay, what he or she describes is domain analysis help you to identify the reusable entities of the system. okay, so that with the help of these, you can achieve the development very easily. Okay, we can able to develop this system very easily. Okay, so in her words, okay, or in Firesmith words, software domain analysis is the identification, analysis and specification of common requirements from a specific application domain, okay, which is typically for reuse on multiple projects within the application domain. Okay, so that is the use of the domain analysis. So object oriented domain analysis in the sense identifying the elements in the perspective of object oriented programming. For example, take the classes, methods, attributes or frameworks which are common or reoccurring, which are reusable. Okay, so that is object oriented domain analysis, right? Here you can see this is a specific you can see the example for application domain. Some specific domain can range from avionics means aviation to banking, and multimedia video games to software embedded which are within the medical devices, so and so on. So the main goal of this domain analysis very straightforward, that is to find or create those analysis classes or analysis patterns that are broadly applicable so that they may be reused. Yeah, later if you want to add the features, okay, with the help of these design patterns or classes, you can able to do very easily. Okay, that is the aim of domain analysis. So these are the few inputs and outputs for the domain analysis. You can see technical literature that comes from the requirements analysis and existing applications. So if there are any existing applications in the particular domain, those are also very helpful at the domain analysis. Same way, customer surveys and expert advice, okay, current and future requirements, okay, these are helps to analysis the domain. So after you've done the analyzing the domain analysis, you can able to produce the output like class taxonomies and reuse standards and functional models and domain languages. You can able to produce for the domain analysis model. Okay, so these are the few inputs and outputs for the domain analysis. So we do have a few modeling approaches, requirements modeling approaches after you done the requirement analysis. So one view we call it as a structured analysis. Okay, one view of requirement modeling is called a structured analysis. What it describes is, it describes about data and and process. Okay, so here data in the sense means, data objects in the sense means data objects are modeled in a way that they can able to define their attributes and relationships, and process here that can able to manipulate the data objects in such a way that they can able to meet the system requirements. Okay, how they transform the data as a data objects, okay, when they flow through the system. Okay, so that's the one view of requirements modeling, that is structured analysis. Let's see the figure that can able to help you understand about a few elements of the requirement analysis model. So first one is scenario based models. As we mentioned earlier, scenario based models are the model that are perspective from the actors or the users. Okay, so few use cases, one scenario based model which we are going to discuss very quickly, and user stories also is a part of scenario based models. Same way, coming to the class models, we do have class diagrams and collaboration diagrams are part of the class models. Okay, behavior models that can able to help you to understand the system behavior with the help of state diagrams and sequence diagrams. Okay, so flow models, how data flows, how information or data or decision flows through the system, can able to help you with the help of DFDs, data flow diagrams diagrams are data models. Okay, so these are the elements of the analysis model. Mainly we are going to discuss about scenario based models. Okay, so let's see that. So scenario based model, as we mentioned, scenario based models are models which are from the perspective of the actors, so they can able to understand what's going on in the system with the help of the scenario based models. Okay, so in this scenario based modeling, first thing what we have to do is creating a preliminary use cases. Okay, so according to Alistair Cogbum, okay, so he characterizes use case as a contract for behavior. Okay, so here contract means the way in which the actor uses a computer based system to accomplish some goal. Okay, so that is the contract. Okay, so in essence, use case captures the interactions that occurs between the producers and consumers of information and the system itself. Okay, so that's about the that is a few parts of the creating preliminary use cases. Okay, let's see. So what should we write for creating a preliminary use cases? Okay, so after you done the requirements gathering meetings, or quality function deployment, that is QFDs, and other requirements engineering mechanisms. Okay, so which are used to identify the stakeholders and define the scope of the problem, and specify overall operational goals, and establish priorities, and outline all known functional requirements. Okay, so all these, whatever we do, identifying the stakeholders and QFDs, okay, whatever you do, for outline all functional requirements. Okay, and describe the things which are going to interact with the system and manipulate the system and manipulated by the system. Okay, so we need to write about it. Okay, so first, before you begin the developing the set of use cases, okay, so first we need to list the functions or activities that can performed by a specific actor. Okay, and so how do you obtain? You can obtain these functions or activities from the list of required functions. Okay, system functions, which we get it from the stakeholders. When we sat with meetings with them, we will get them. Yeah, so after you got these functions, you can able to design the use cases. Okay, and sometimes we have to go to the extent and develop activity diagrams and Swimlane diagrams, which we are going to see in few minutes. Okay, so here is the example, the say home surveillance function. Okay, so this surveillance function, okay, have an actor called homeowner, and what he perform the functions on that system is select a camera to view, that is one function, and request thumbnails from all the cameras. You can able to see all the cameras at the same time with the thumbnails of all the cameras, and display camera view in a PC window. So that means you can able to select the camera view, and you can able to zoom out and zoom in of particular camera, and one more function is selectively record camera output. You can able to record the particular camera output and replay the camera output. That means you can able to replay the already recorded camera output. Okay, and you can able to access camera surveillance via the internet. Okay, these are the few functionals that can able to perform by the homeowner actor. Okay, so yeah, with the help of these functions, we can able to write use case like this. Okay, so the use case title would be access camera surveillance via the internet. Okay, display camera views. Okay, ACS DCV in short we call him, and here we need to mention the actor, and the actor here is the homeowner. We need to write all the functions with the number. The first one is the homeowner logs into this Safe Home Products website. So and okay, that is the first function. And second function would be the homeowner enters the his or her user ID. Okay, the third function is the homeowners enter the two passwords. Okay, for for login and authentication. Okay, and the next one is then after we can successfully log into the system can able to display all the major function buttons. Okay, it's like a menu. Okay, so the homeowner select the surveillance from the major function buttons. Okay, that is the fifth thing what he could do. And the homeowner selects the pick a camera, and system displays the floor plan of the house. Okay, and the homeowner selects the camera icon from the floor plan, and the homeowner selects the view button. Okay, and the system displays viewing window that is identified by the camera ID, and the system displays video output within the viewing window at 1 frame per second. Okay, so these are the functions which are ordered in a sequence. Okay, so that is the simple use case, right? Yeah, so that is how you create the preliminary use case. Okay, so I am repeating again. So you have to after collecting the requirements, you need to identify the functions what system is going to perform. So with the help of these system functions or activities, you need to create a preliminary use case by noting down all the functions in order, and you need to mention the title, and you need to mention the who is the actor going to perform these functions. Okay, so after you creating the preliminary use case, sometimes you need to refine this preliminary use case. Okay, so yes, how so we need to evaluate whether all the functions which are mentioned in the preliminary use case are valid by asking few questions. Okay, so what are those questions here? Can the actor take some other action at this point? Okay, so if yes, so what would it would be? Okay, so is it possible that the actor will encounter some error condition? Okay, at particular point. Okay, so if he encounters the error, what it would be? And is it possible that the actor will encounter some other behaviors at this point? Some other behavior like a system going to stuck, or internet disconnected. Okay, so what would be the consequences? Okay, what would be the reaction of the actor? Okay, we need to mention all those in this refining preliminary use case. Okay, not only that, okay, Kirkburn recommended asking few questions. Okay, what are those? So are these cases in some validation function? Okay, sometimes validation function is necessary, so we need to use the validation function for that particular activity. Okay, so so is any function will fail, okay, at particular point of time. Okay, so what would it would be? Okay, can poor system performance result in unexpected or improper user accessions? Yes, we need to ask these questions. Okay, according to the Cockburn. Yes, so after you identified these questions, after you ask the questions, based on the answers you will get, you need to mention the exceptions you will encounter during using the system. Okay, which is within the use case, and sometimes in some cases an exceptions will be precipitate. Okay, the development of another case. Yeah, sometimes in exceptions are the ordinary cases, extraordinary cases, where that can be depend upon the another activity in the use case. Okay, how to handle the error, what lead, what other action that would lead to this error. Okay, everything would be noted, right? So that's the refining the preliminary use cases. Okay, so then after you done with the refining, after you think you're done with the refining the preliminary use cases, so you need to write the formal use cases. That's the here the work starts. Okay, so yeah, every modeling has its limitations, so that the use cases also. Okay, so use cases are as good as as its writer. Okay, so if you are good at, if you are now good at understanding the requirements and functionalities, yeah, the use case would be also good, right? So if the requirements are unclear, okay, so that your use case, okay. Yes, as you know, if you see the second part that says, use case focus on functional and behavioral requirements. Okay, so it is very inappropriate for non-functional requirements. Yes, use cases focus on only functional behavior of the requirements, but not non-functional requirements. Okay, so yeah, so for the example which we have discussed, surveillance system, okay, surveillance home, so the requirements would put into in the use case like this. Okay, so homeowner will access the camera surveillance via the internet, and he can able to configure a safe home system parameters, and he can able to set alarm when he going away from the home. Okay, and here another one is cameras actors, or external entity is camera. Okay, so this is how can able to write the use case for whatever the system you are going to build based on the use case scenario based modeling. Okay, sometimes use case is not sufficient to understand the system. Okay, such times we need to go extend our use cases, and we need to develop few other diagrams. Okay, one of them is activity diagram. So activity diagram is like flowchart diagram that can have a rounded rectangles that can able to tell you what function it is going to perform, and arrow marks that can able to tell you the flow of the direction, and diamond shapes tell you that the decision system, and solid horizontal line help you to understand the parallel activities going to happen. Okay, so with the example that would be very easy to understand, right? Let's see the example. Here you can see for same example, home surveillance system. So first starts with the dotted symbol, then first functionality the user performs is they enter the password and user ID. If it is correct, okay, he will enter into the main function of the system. Okay, if it is wrong, it will ask you to re-enter the password. Okay, so based on few attempts, it will so exit, or you can, if successful attempt of the entering the username and password, you will enter into the menu. Then you can able to select the surveillance. Okay, so whatever the surveillance camera you want to check, okay, that is the decision symbol here. So that can able to do the few things, that is select specific camera thumbnails and select a camera icon. These two are horizontal same parallel activities, right? So then user can act, homeowner can able to view the camera output in a tabled window. Okay, then he can able to prompt for another view. Okay, if he want, he can again go back to this decision diamond shape, or diamond shape fill, otherwise he can able to exit the system. Okay, so this is simple example of activity diagram that is the extent to the use case. Okay, another one is swimlane diagram. Swimlane diagram is also one more use case UML model that can able to supplement the use case, right? So Swimlane diagram also have the few actors who are involved in the system itself also there, and they can able to do the functionalities as we mentioned the activity diagram. Okay, which is similar to activity diagram. Let's see the example again. Home surveillance system. Here homeowner and camera and interface itself is a system. So homeowner will enter the password. If it is correct, okay, he will enter into the system. He will be entered into the system. Okay, okay, interface will validate the password. If it is correct, it will allow the homeowner enters into the next step, that is menu, displaying the menu. If it is wrong, it will ask you to re-enter the password. Okay, so yes, then he can able to select the major function. Okay, and then he can able to select the surveillance. Okay, so after the homeowner select the surveillance, he can able to see two functionalities. Okay, select the specific camera of thumbnail or select a camera icon. Okay, if he after he select the appropriate output, camera will display the appropriate output, and homeowner perform the function called view camera output in a labeled window. Okay, after that, interface will prompt for another view. Okay, so if you want, he can again go back to same surveillance, otherwise he can exit from the function. Okay, so this is the example for Swimlane diagram. Okay, so yeah, I think that's about this use case models. Okay, so thank you. So all the examples and information taken from the software engineering a practitioner approach by Roger S. Pressman. So thank you very much.